All right, good morning everyone, and we are going to discuss today the introduction to integration. What is a concept of data integration? So when we say data integration, in its simplest form, is the capture of movement of data from one database or flat file on source system to another database or flat file on target system. Most of companies are already performing some type of data integration, whether it is backing up network servers, performing mirroring for high availability, or replicating key databases to business intelligence application. But with the sheer number of integration tools on the market, along with the different approaches, each employee choosing an effective solution can be both difficult and time consuming. So this is in relation to the integration of different database from one source system to another. Meaning to say, if you have another database such as let's assume na ito ay for student, then magkakaroon din siya ng relation ng integration of another database, let's say not only for the student but as well yung sa ating mga employee and the like. Now, there are different alternative names for this concept of data integration. One of which is what we call the KDD, or the knowledge discovery, that is used for mining from databases, or knowledge extraction, data pattern analysis, data archaeology, data dredging, information harvesting, and of course the business intelligence. It also has the interoperate and exchange information with other information systems that could be adaptable to users, diverse requirements, and evolve with time. Not only that, it also uses data integration technologies to access several source systems on various platforms, transform and cleanse, purify the data, and load the resulting data into the Oracle database. Uh, as well as it extract or mine knowledge from large amount of data. Data integration is also independent of source, location, data model, syntax, and semantic variations. Data exchange, however, has on between source and destination, and used data integration technologies to extract the relevance data and build new data. Information integration from a database perspective is also used, as well as the integration method and architectures are done by mediator approach and information integration scenario and scope. There are also a simple, complex, multiple worlds, data duplication, inconsistency, and system proliferations. And of course, it also provides single source of information to support the portfolio management division. So lahat ng yon could be used as an alternative ways or alternative means of data integration. Now, what are the goals of data integration? We have different uniform query access to set of data sources handled. Number one, we have the scale of sources, which is from tens to millions. The heterogeneity, which is from different kinds of source, from different databases and flat files. Autonomy, we have in the autonomy, we use similar and unique data, and semi-structured, that is used for different semi-structured databases and files. We also have the model-based mediation, which have the basic ideas and architecture lifting to knowledge sources. We also have the glue maps that includes domain maps and the process map, the formal framework or the description logic and frame logic, and the ongoing research, which is of the mix of database and the KR techniques. Now, the database has the different perspective. We have the scalability to efficiency, reusability that declared or has a declarative queries. Ito yung kagaya ng queries na ginagamit natin during the time ng ating uh, process ng ating database management system. And of course, the XML-based mediation that is based on querying semi-structured data and XML. As you can see in our monitor, we have the evolution of the database system technology. For the data collection and database creation, it was uploaded or it was used during 1960s and earlier. That is called as the primitive file processing. It also has the database management system, which was being used in 1970s and early 80s, which has the hierarchical and network database system, the relational database system. All right. So we also have, as I've said, that we have the database management system that was introduced in the early 70s or in 70s and early 90s. This database management system has the hierarchical and network database system. We have the relational database system, which I already have discussed in your database fundamentals, the data modeling tools, which uh, focus on the entity relationship model or relational model, the indexing and accessing methods, the query language, user interfaces, and a lot more. Now, this database management system was able to enhance, and of course, not only that, they were also used to uh, have the enrichment as the database uh, advanced database system. It was presented in the market in the mid 1980s. This advanced database system has advanced data models, extended relational, object relational, and advanced application, which has the spatial, temporal, multimedia, active, stream, and sensor, scientific, and engineering knowledge base. We also have the advanced data analysis or the data warehousing and the data mining. This data mining was introduced to the market to late 1980s up to present. Now, this data mining will be used in our lesson for this subject. And data mining knowledge has discovery, generalization, and classification. This will be discussed to you later on of this program. The advanced data analysis also has the advanced data mining applications. We will be using Excel, SPSS, and rapid mining technology. And of course, we have the web-based databases that was also introduced in 1990s up to present. These web-based databases has the XML-based database system, integration with information retrieval, and data and information integration. All of these were also able to enhance, innovate, and they are now called the new generation of integrated data and information system. All right, next. So there are possible integration schemes that is being used in these kind of integrative programming uh, technologies. One of which is it include no coupling, loose coupling, and semi-tight coupling and tight coupling. In the no coupling, it means that the data extraction system will not utilize any function of DB or DW as the repository of data. It may fetch data from a particular source, such as the file system, in which it processes data using some data extraction algorithm and then store the extracted result in another file. That system, through simple, suffers from several drawbacks. First, a database system provides a great deal of flexibility and efficiency on storing, organizing, accessing, and processing of data. Without using a database warehouse system, the integration system may spend a substantial amount of time finding, collecting, cleaning, and transforming data. In database or data warehouse system, data tend to be well organized, indexed, cleaned, integrated, or consolidated so that finding the task relevant, high-quality data becomes an easy task. So there are many tested scalable algorithms and data structures implemented in the database system. It is also feasible to realize efficient, scalable implementation using such system. Moreover, most data have been or will stored in database systems without any coupling of such system. To extract data, making it difficult to integrate such a system into an information processing environment. Thus, no coupling represents a poor design. Next is the loose coupling. Loose coupling means fetching data from a data repository managed by database system. It performs data structure or extraction and then storing that extracted result either in a file or in a designated place in a database or data warehouse. The loose coupling is better than no coupling because it can fetch any portion of data stored in databases or data warehouse by using query processing. So this is it is in relation to our database management system that we are uh, process the query, we index, and other system facilities. It also incurs some advantages of flexibility, efficiency, and other features provided by such system. However, many loosely coupled systems are main memory based. So, medyo ano siya sa memory na sinasabi. Kasi it really focus on or it resides in the memory that is being used by our computer. Because of this, it does not explore data structure and query optimization methods provided by your database. It is also difficult for loose coupling to achieve high scalability and good performance with large data sets. So if ever that we have more than thousand of data sets to be used, this loose coupling is not applicable. Another thing is the Semitide coupling. It means that besides linking a knowledge discovery system to a database system, efficient implementation of a few essential data mining primitives, it is identified by the analysis of frequently encountered data mining or extracting functions that can be provided in the database system. Not only that, these primitives can include sorting, indexing, aggregation, histogram analysis, multi-way join, and pre-computation of some essential statistical measures such as sum, count, maximum, minimum, standard deviation, what else? Those are some of the statistical treatment that could be used. Well, anyway, I just want to reiterate that the use of statistical treatment is being implemented as well in this integration. Uh, Not only that, some frequently used intermediate mining can be a result of a pre-computed and stored in a database or data warehouse system because these intermediate extracted results are either pre-computed or can be computed efficiently. So this design will help the performance of extracted mining system. Next is the tight coupling. This means that an extracting system is smoothly integrated into the database or the data warehouse system. So the data mining is a subsystem that is treated as one functional component of an information system. The tight coupling has a data extracting queries and functions that are optimized based on extracted query analysis, data structures, indexing scheme, and query processing method for a database. With the different technology advancement, database and data warehouse systems will involve and integrate together with one information system with multiple functionalities. Meaning to say, this will provide an information or uniform information processing environment. So this approach, the tight coupling, is highly desirable because it facilitates efficient implementation of data extracting functions, high system performance, and an integrated information processing environment. The knowledge discovery data from AKDD. Alternatively, other views data extracting is simply as essential step in the process of knowledge discovery. So the knowledge discovery as a process consists of an iterative sequence of the following steps. So we have a what we call the data cleaning to remove noise and inconsistent data. So yun yung isa. We have to clean the data for us to remove the noise and inconsistent data. Next is, of course, the data integration where multiple data sources may be combined. And then afterward, we have the data selection, which in which the data are relevant to the analysis and task and retrieved from the database. Number four is the data transformation, where data are transformed or consolidated into forms or appropriate for extracting by performing summary or aggregation operations, for instance. Next is the data mining, which is very essential in the processing of intelligent methods that applied in order to extract data patterns. Next to that is the data evaluation. This is used to identify the truly interesting patterns representing knowledge based on some interesting measure. And number seven is the language presentation, wherein visualization and knowledge representation techniques are used to present the extracted data to the user. So there are different major issues in the integration scheme, one of which is what we call the different kinds of data in the databases. As we Because different users can be interested in different kind of knowledge, data extraction should cover a wide spectrum of data analysis and knowledge discovery tasks, including the characterization, discrimination, association, and of course the correlation analysis, as well as the classification, the prediction, clustering, and a lot more, which includes trend and similarity analysis. Kasi may mga halimbawa, gusto natin malaman yung mga trend analysis. Let's say, for instance, ngayon we are focusing or we are experiencing this kind of pandemic. What are the trend analysis of or similarity analysis to what we are experiencing today to other countries. So, parang ganun yung we have different kind of data in databases. So, these tasks may use the same database in different ways and require the development and numerous data mining extraction techniques. Next is the interactive mining of knowledge at a multiple levels of abstraction. Because it is also difficult to know exactly what can be discovered within a database, the data extraction process should be interactive. When we say interactive, for a database containing a huge amount of data, appropriate sampling techniques can be first applied to facilitate interactive data exploration. Interactive interaction or extraction allows the user to focus the search for patterns, providing and refining data extracting requests based on return result. Specifically, knowledge should be mined by drilling down, rolling up, and pivoting through the data space and knowledge space interactively. In this way, the user can interact with the data extraction system to view the data and discover patterns at a multiple granularities and from different angles. Not only that, we have the incorporation of background knowledge. When we say background knowledge class, this is the information regarding the domain under the study. It could be used to guide the discovery process and allow the discovered patterns to be expressed in concise terms and at different levels of abstraction. So the domain knowledge related to databases in this issue is related to databases such as the integrity and constraints and deduction rule that can help focus and speed up a data extraction process or judge the interesting of discovered pattern. We also have the data extraction, query languages, and ad hoc data extraction. The relational query languages, such as the SQL, allows the user to pose ad hoc queries for data retrieval. In similar, we have a high-level data extraction query language need to be developed to allow users to describe the ad hoc data extraction task by facilitating the specification of the relevant sets of data for analysis, wherein the domain knowledge, the kind of knowledge to be mined, and the condition and constraints to be enforced on the discovered pattern. So those language should be integrated with databases or data warehouse query language and optimized for efficient and flexible data mining. Next to that is the presentation of visualization of data extraction result. So when we mean by the data extraction result, the discovered knowledge should be expressed in a high-level language, the visual representation, and other expressive forms so that the knowledge can be easily understood and directly usable by humans. Which means to say that you could use different flow chart, different chart for us to be able to present the data, especially if there are crucial data extraction systems to be interactive. This requires the system to adapt expressive knowledge representation techniques such as trees, table, graph, chart, cross tabs, matrices, or curves. So those are the different presentation and visualization that you could use for us to be able to present the data to your reader. Next is handling noisy or incomplete data. So this is one of the major problems that we are facing because there are some noisy or incomplete data that is stored in a database that may reflect noise, exceptional cases, or incomplete data objects. When extracting the sum of the data regularities, object may also confuse the process, causing the knowledge model constructed to overfit the data. So as a result, the accuracy of the discovered patterns can be also poor. So we have to use the data cleaning methods and data analysis method that can handle noise that are required. Next is the pattern evaluation, which is the interestingness problem. A data extraction system can also uncover thousands of patterns. So many of the patterns discovered may be uninteresting to a given user, either because they represent common knowledge or lack of novelty. There are also several challenges that also remains regarding the development of technique to assess the interestingness of discovered patterns, particularly with regards to subjective measure that estimate the value of patterns with respect to a given user class based on the belief or the expectation. Alright, next. We also have some of the performance issues that includes the efficiency, scalability, and of course the parallelization of data extraction algorithm. One of which is the efficiency and scalability of data structure algorithm. This one is if we have the effective extract information from a huge amount of data in the databases. Data extraction algorithm must be efficient and of course scalable. In other words, if we are going to have a runtime of a data extraction algorithm, it must be predictable and of course acceptable in a large databases. From that database perspective on knowledge discovery, efficiency and scalability are also the key issues in the implementation of data extracting systems. So many of the issues discussed are extracting methodology and user interaction that must also consider efficiency and scalability. Next is a parallel distributed and incremental extraction algorithms. Uh, in these performance issues, there are a huge size of many databases and the wide distribution of data and computational complexity of some extraction methods were in a factors motivating the development of parallel and distributed data extraction algorithm. So those algorithms divide the data into partitions which are processed in parallel. As a result, from the partitions, they are being merged. So, however, the high cost of some data extraction processes promotes the need from incremental data extraction algorithms that incorporate database updates without having to mine the entire data again. Of course, this will always be from the scratch. So those algorithms perform knowledge modification incrementally to amend and strengthen with what previously discovered. So issues relating to the diversity of the database types are, of course, handling the relational and complex types of data. As you all know, there are different relational databases and data warehouse that are widely used, and these the development of efficient and effective data connection system for such data is also important. But however, other databases may contain complex data object, hypertext and multimedia data, spatial data, temporal data, or transaction data, which cannot be avoided. It is also unrealistic to expect one system to extract all kinds of data. This is given to the diversity of data types and different goals of data extraction. Then again, the specific data extracting system should be constructed for extracting specific kinds of data. Therefore, one may expect to have different data extracting system for different kinds of data. Next is extracting information from heterogeneous databases and global information system. In this, we have a local and wide area computer networks that connect many sources of data, forming huge, distributed, and heterogeneous discovery. The discovery of knowledge from different sources of structured, semi-structured, and unstructured data with diverse data semantics poses great challenges of data extraction. The data extracting may also help disclose high-level data regularities in multiple heterogeneous databases that are also unlikely to be discovered by simple query system and may improve information exchange and interoperability in heterogeneous databases. And I think that's the end of our discussion for the different integrative programming techniques. If you have any question for this is just a theory class of the integrative programming technologies. After this, we'll be having a discussion for the data processing. Thank you so much for listening, guys.